We're now going to look at complex calculations when it comes to exponents. Now in this first example we have 6 to the power of 2010 times 10 to the power of 2011 over 4 to the power of 2010 times 15 to the power of 2009. Now the first thing I always try and think about when I see large exponents is sometimes when you have large exponents you can actually take maybe that 2011 and try and change it to 2010. So for example you'd say this would become 2010 multiplied by 10 to the power of 1. Then maybe you can do something with that. Although in this case I don't think that is what we're going to do. The first thing I'm going to try is to look at these because they can actually be broken up into their prime factors. This looks more like the type of question where we multiply exponents and we just have those set out steps that we kind of follow. We prime factorize, multiply into the brackets and group the same basis and simplify. So I'm going to go that route. So this is just 2 times 3 to the power of 2010 multiplied by 2 times 5 to the power of 2011 all over 2 squared to the power of 2010 multiplied by 3 times 5 to the power of 2009. Okay, now I'm going to take the exponents into the bracket and put it to each base. 2 to the power of 2010 multiplied by 3 to the power of 2010 multiplied by 2 to the power of 2011 multiplied by 5 to the power of 2011 all over 2 to the power of 4020 multiplied by 3 to the power of 2009 multiplied by 5 to the power of 2009. Okay, so that was a mouthful. So now we've got like the same bases of 2s, of 3s and 5s. And remember, when you multiply the same base, you add the exponents. When you divide the same bases, you subtract the exponents. So starting with base of 2, all the exponents, all the bases that are in the numerator, I'm going to add their exponents, plus 2011, and subtract the ones in the new denominator. Okay, bases of 3, 2010 minus 2009, and 5, 2011 minus 2009. Alright, so this is going to actually simplify to some smaller numbers because 2010 plus 2011, that gives me 4021. 4021 minus 4020 is just 1. Okay, and 3, 2010 minus 2009 is 1. And then for 5, 2011 minus 2009 is just 2. So 2 times 3 is 6, 5 squared is 25, and 6 times 25 is 150. Then for example 2. Alright, so this is a complicated one. So let's just look at like what we're going to do for our first step. Here we have a square, so what we can do is expand this and multiply it out. We can decide if we want to change this to 1 over a or not, like taking the exponent is a negative, so we take the base down and make the exponent positive. If you change it into a fraction, you just use your fraction rules. If you don't, you just use your exponential laws when multiplying that out. Here, definitely we can't, the only thing we can do here is to take the base of a minus 1. This counts as the entire base. Take that down, put it over 1. Here as well, best way to handle this would be to make these exponents positive. If they are multiplied together, it's still easy to use your exponential laws, but if it's like added, then it's definitely better to, or I think maybe the only way is to make them positive and use your fractions. So you'll see what I mean now. So expanding this, I am going to leave this in its exponential form. Okay, and that we just put over 1. Okay, a minus 1. Okay, so all of this is now over, so that becomes 1 over a squared, then plus 2 over a. Now notice, common mistake here, the only one that applies to the negative 1, the negative 1 only applies to the a. So it's only the a that goes down to the denominator, not the 2. If this had a bracket here, 2a as a whole would have gone down, but because it's 2, then a to the power of negative 1, only the a goes down, plus 1 over 1. All right. Then what I'm going to do is this, I'm going to add, and we need the lowest common denominator, which is a squared, so I'm going to multiply top and bottom with a, multiply top and bottom with a squared, and in the numerator I am going to multiply out these terms, FOIL them out, but I'm going to put it over a minus 1, because it's just like, let's say this was over 1, you'd say this times by 1 over 1 times by a minus 1. Okay, so a times a is just a squared. Then a times by negative is a negative a, so this is 1 minus 1, so that becomes 0. And then again, a to the power of negative 1 times by a to the power of positive 1 becomes minus a to the power of 0. And minus times minus is a plus. Minus 1 plus minus 1 gives me minus 2, so a to the power of negative 2. So all of this is still over a minus 1, and then that is over this. So with this we've got 1 plus 2a plus a squared, and that's all over a squared. Okay, then we can simplify this. This we can put in like a fraction, and then that we can change to 1. So minus 1 is minus 2. This then becomes a squared minus 2 plus 1 over a squared, and then that is over a minus 1, and that is all over. So this can be factorized, but I'm just going to rearrange it first. A squared plus 2a plus 1 over a squared. Okay, now we need to be careful. Now things are going to get a bit more complicated with the fractions, because what's going to happen now, we've got this fraction, okay, over this fraction. So it's basically take this fraction divided by that fraction, and we can do that. But now we're even going to have a fraction inside, because we've already got a fraction inside a fraction, but we're going to have a fraction inside a fraction inside a fraction. So putting this over lowest common denominator, let's put this over 1. So putting it over a squared, we multiply a squared with each term. Okay. Okay, so this then becomes, if we put it all over a squared, this becomes a to the power of 4 minus 2a squared plus 1, and that's all over a squared. All right, then it's divided by a minus 1. Okay, and that's now the top fraction, divided by, so I'm just expanding them, a squared plus a 2a plus 1 over a squared. So what I'm going to do to simplify these things, I'm going to now change this into a multiplication sign and swap these two around. In the same step, I'm going to just factorize this as well. Okay, and I'm going to factorize that. Okay, so this is going to be a squared, this is trinomial factorization, a squared minus 1 and a squared minus 1. Okay, that is still over a squared, and that is all over a minus 1. Multiply by a squared over, and if I factorize this, I get a squared, or not a squared, a plus 1, a plus 1, a plus 1, a plus 1. Right. Then, if I put this over 1, you can see that we've got actually, like, we can multiply, let's put this in square brackets, this together and that together. Okay, but what happens is this factorizes further. All right, it becomes a plus, okay, actually this actually cancels. Let's just get that out of the way. This cancels. All right, then we have a plus 1, a minus 1, a plus 1, a minus 1. Okay, all over a plus 1, a plus 1. Okay, and that is the numerator multiplied together. Now that's all over a minus 1. Okay, these guys cancel. Okay, and then that's just over 1. So this is just going to be a minus 1 over 1, which we can drop there, which is over a minus 1. And then that cancels, which just leaves us with a minus 1. Okay, so there was a lot of complex calculations, so I would actually maybe recommend that you try it on your own without looking at this, because there's actually a lot of rules that apply here, which are nice to apply and practice.